Hello, welcome to the first lecture all about quadratic functions and their graphs. So this is the first lecture. In this lecture or this video, I will go over what a quadratic graph looks like and the different equations of a quadratic graph. So just like a linear graph, you have these different forms of equations. So yeah, we're just gonna go over what it looks like in the different equations. So yeah, let's go over what does a quadratic function look like. It can be concave up, just like this. It could be B. It could also be concave down. Whoops. It could also go sideways. Now, sideways, that's more of a conic section. We're not going to go over that, these forms. It's only concave up and concave down. But it is important to know that it is possible that a parabola, because a parabola is technically a quadratic, it can look sideways either on the right or left. So just let you know. Okay, so just like a linear functions, there are different forms of a quadratic function. So the first form is standard form, which is y equals ax squared plus bx plus c. Here, let me give you an example. So an example would be like, I'm totally making this up, x squared plus 6x plus 12. So you've seen this before somewhere. So just know that this is a quadratic in standard form. The other form is vertex form, which is this should be parentheses. Y equals a parentheses x minus h raised to the square plus k. I like this form because it's easy to find the vertex really quick. With the standard form, okay, so wait, I'm going way ahead. Vertex is going to be on the next lecture. I don't want to confuse you. So this is another form. An example would be y equals 3 parentheses x minus 5 squared plus 2. Okay, so that is vertex form. X-intercept form is pretty much in the most factored form it can be. So it's y equals a parentheses x minus p times x minus q. So an example would be like y equals 3 x minus 2 x plus 5. It's in the most factored form you can be. Okay. And then 4 and 5, that's more of a conic section. But I just wanted to put it in just to make sure that parabola and quadratics are the same. So this is still technically a form of a quadratic function, but we're most likely in this course, it's mostly 1 through 3. That's it. Okay. Now later on, you might have to transform from vertex to standard or standard to vertex. That's kind of like the hardest part, but that's completing the square, but that'll be another lecture. I just want to point that out. Okay, let's move on. Let's go over the characteristics of a quadratic graph. So let me clear this. So what are some of the characteristics of a quadratic graph? Rule 1, graph can be concave up or concave down. So you've seen that before. You see how it can be concave up, concave down. Graph can have a horizontal shift, vertical shift, reflection, stretch / compression, just like the other graphs we were introduced. Graph has a max or min, also known as a vertex. Horizontal shift and vertical shift is considered a vertex. So that's only related if it was in vertex form, right? So if it's in vertex, it's easy to find the vertex. So what do I mean by vertex, by the way? A vertex, so for example, let's say this is a quadratic concave up, right? The vertex is either the lowest point or the highest point. So would be the vertex. And if it was concave down like this, the vertex would be right here. So just note that vertex is either the highest point or the lowest point. A graph has an axis symmetry. So what is an axis symmetry? It's pretty much like a vertical asymptote, and it's pretty much the x value of the vertex. So asymptote axis symmetry is an equation. It's going to be x equals a constant, and it's the x value of the vertex. For example, let's pretend the vertex on this graph was at 3, 3, -1, right? So the axis symmetry is x equals 3. It's pretty much the x value of the vertex. And what does that look like? It's basically a vertical asymptote. So you would draw a vertical asymptote like this. And then this would be x equals 3, just like that. Okay, so yeah, so that is the axis symmetry. It's pretty much the x-coordinate of the vertex. Graph can have an x-intercept or no x-intercept. So, and it says can use discriminant rule to determine the amount of x-intercept. That will be in another lecture, but basically the discriminant rule determines how much x-intercepts or how much zeros you have. Sometimes your quadratic function may not go through the x-axis. So what I mean is a quadratic can go like this. See how it doesn't touch the x-axis at all. So you may or may not have an x-intercept. So that's very important to know. Okay, let's move on. Okay, let's go over quiz 1. I'm just gonna put it in the same video lecture. So go ahead and pause if you need to write out the problem or if you just need time to look at it. Yeah, so let's start with number 1. True or false, y equals 1/2 or -1/2. And it's a little bit, I don't know if you can see this, but this should be in parentheses. It's in red. So if you're a bit colorblind, let me write out the parentheses. So y equals -1/2 parentheses x plus 2 parentheses 2x minus 3 is a form of a quadratic function. True or false, and what form? Okay, so go ahead and take some time to look at it and so yes, is it true or false? I'm going to say definitely true. It is a form of a quadratic. It is in x-intercept form. So it's in this form, y equals a parentheses x minus p parentheses x minus q. Okay. Okay, number 2 is what is the highest or lowest point of a quadratic graph called? So yeah, what is the highest or lowest point of a quadratic graph called? Okay. The answer would be vertex, right? So if you recall, sometimes a graph can be concave up like this. Your vertex is here, which this would be the lowest. It's also considered, so this is the lowest, it's also called a vertex. It's also called your min. Sometimes they'll ask for min or max. So when they ever say min or max, you know it's vertex related. And then if it's concave side down, you have what's called, the vertex would be right here, that would be your max. Okay. Good. Last one, number 3, true or false, quadratic graphs must always have an x-intercept. Okay, the correct answer would be false. It may or may not always have an x-intercept. So this is related to the discriminant. Sometimes it will cross the x-axis like this, and sometimes it may not. So we'll learn about that more when we learn about discriminant rule. Okay. Okay, so this was the first lecture of this course. Okay, and then the next the next lecture should be graphing a quadratic function in vertex form. Okay, so yeah, that wraps it up for this lecture.